talking about interest. And if you don't know what interest is, basically when you go to take out a loan, let's say you want to go buy a car, and odds are you probably don't have the cash on hand to buy a car outright. Usually it's like tens of thousands of dollars. So what most people do is they go to the bank or work with some financial company and ask for a loan. And so basically what they'll do is they'll let you borrow the money to go buy the car, but they're not going to do that just out of the goodness of their heart. Okay, they're going to charge you for borrowing that money. And the amount that they charge you for borrowing that money is called interest. Okay, so anytime you take out a loan, whether it be for a car or a house, maybe you're taking out like a small business loan, whatever the case may be, you don't get that money for free. Okay, you pay it back, but you pay it back with interest, which is that extra little percent that the bank or whoever the lender is charging you for taking that money out. Now, interest can work against you in that way, but it can also work for you. Like if you invest your money into a savings account, most savings account will essentially, or banks will pay you for you to like keep your money within their system, right? So if you go to like a Chase Bank or whatever the bank may be, and you deposit money into a savings account, typically what they'll do is they'll like kick you back a little bit every month or maybe once a year. And that money that they're giving you is the interest. So it can work both ways. It definitely benefits the lender because it gives them an incentive to let you borrow money because they know they're going to get more back than they gave you. But taking out a loan is not necessarily a bad thing, even if you have to pay back more than you borrowed, because it allows you to do things that you couldn't otherwise buy outright. Like, if you want to go buy a house, your average person can't afford to just go out and straight up buy a house, right? Houses are hundreds of thousands of dollars, especially around this area, right? And most people just don't have that cash on hand. So what most people do is they'll take out what's called a mortgage, which is just a fancy word for saying a loan for a house, and they'll essentially borrow the money to buy the house, and then most mortgages are like over a 30-year period. They'll pay it back over those 30 years, but with interest. So the interest is essentially the bank's way of making money off of lending you money. So that's what interest is. Just kind of there's a lot more to it, a lot more nuance, but that's kind of the general idea. It's just basically like an extra charge for borrowing money. And so there's two ways. There's one way that we can calculate. If we just have basic simple interest, we have this simple interest formula to calculate it based on how much you borrow, what the interest rate is, the percent that they're going to charge, and the time. How long is it going to take you to pay it back? Now, we're not really going to do too much with this simple interest because it's not exponential. Like you can see, there's no exponential function going here. But I think it's kind of interesting to see how this gets calculated, kind of like a simple way. But what we're going to focus most of the time on today is on compound interest, which is a little bit more involved. So simple interest can be calculated with this formula, I equals PRT, where I is the total interest that you're, like, let's say if you're investing something, and can I spell here, interest, that you either earn or you pay, right, depending on which side of the transaction you're on. Okay, if you're borrowing the money, you will pay interest. If you're lending the money, you will earn interest. Okay, so the P stands for principal. Okay, not like the principal at a high school. Principal in this context stands for the initial amount. Okay, it's either the initial investment or the amount that you borrowed, like the initial amount that you took out. So it's the initial value. The R is going to be the interest rate. And in these problems, the interest rate is generally given as a percent, and you'll want to convert that to a decimal to make this work. So just as a little note, we want that interest rate as a decimal, even though it'll be typically given to you as a percent. And then finally, T, that's time. Typically, this is going to be in terms of years, but it might be something else. I think all the problems I'm going to give you are in years, but you could use this formula if it were calculated like with some other time increment. So that's the formula. And what you're going to see is like, even when we get to the compound interest, which is a little bit more complicated of a formula, most of these problems just boil down to making sure you're picking out the right numbers out of the problem and then plugging them into the equation to get the right answer. So it's really more about understanding how the formula is set up and what each of the variables represent and how to extract them from the word problem. Because I'm going to give you these formulas. You do not have to memorize these. So let's do a couple examples just with simple interest, and then we'll move on to compound interest. So number one here says that Sam opens up a savings account with $200, okay, which pays simple interest at a rate of 5%. So our initial amount is the $200. That's the principal. The rate is 5%. And honestly, that's a pretty high rate. Like if you really go out and try to find a savings account that pays 5% annual interest, let me know because I will transfer my money there today. Okay, that's a little higher than really what you would find. So 0.5%, 5% is 0.05. That's the R. How much interest will he have in 15 years? So that's going to be our T, our time. So the equation that we're going to be working with, I know it's on the previous slide here, but I just want to write it down here, is I equals P times RT. And so the equation that we'll write to model this scenario will be 200, that's the principal, times the rate, which is 0.05, times the time, which is 15 years. Now, this is going to calculate the interest. It's not going to calculate how much money is in the account at the end. That'll be a separate computation. When we want just the interest that he's going to earn, that's what this formula calculates. It computes the interest alone. So all these problems are going to be calculator problems. You don't have to do any of this by hand. So let's see here, 200 times 0.05 times 15 gives me $150. So that means over the course of 15 years, the bank gave him $150 for leaving his money in that bank. Yeah. Now, you might be wondering, why would the bank do that? What incentive does the bank have to, give you money for holding your money? Yeah. So something worth thinking about. Why would they do that? How much money is in his account at the end? So the final value of his savings account is going to be the amount that he put in there plus the amount that the bank gave him in interest. So the total will be the principal plus the interest. In this case, 200 plus 150. Should be $350. Any questions about this problem? The simple interest is really straightforward. It's as long as you're plugging in the numbers correctly and using the calculator, it's kind of hard to get these problems wrong. The next one, it says Karen borrowed $11,500 from the bank to help her meet her bills. She's being charged at a rate of 8.5%. That is really high for 10 years. How much will Karen have to pay back to the bank at the end of 10 years? So now we're on the flip side of it. The previous problem, you're putting money into a savings account. Here, you're borrowing money. So instead of being the lender, Karen is the borrower. But still, you're going to compute the interest in the same way. So the $11,500, that's the principal. That's the initial value of the loan. The rate, 8.5%, as a decimal would be 0.085. So be careful there. It's not 0.85. That'd be 85%. And then for 10 years, that's going to be our time frame. That's our T. So we'll use that same formula, that interest equals the principal times the rate times the time, to model this scenario, 11,500 times 0.085 times 10. And then that expression can be used to calculate how much interest she's going to pay back. It's going to be kind of a lot, okay? And it is over the course of 10 years, but I guess she got to pay those bills. They're not going to pay themselves. But this is the big downside to borrowing money, right? Is you have to pay back a lot more than what you borrowed. So go ahead and calculate this out. 11,500 times 0.085 times 10 is $9,000. $775. So that's not how much she paid back. That's just the interest that she paid back. She still has to pay back the original loan. This is essentially the charge the bank is or this is the amount that the bank is charging her for that loan. So the total amount that she pays back is going to be the $11,500 plus the $9,775, and that equals, well, let's see what that equals. 1,500 plus 9,775 is $21,275. That's kind of a lot of extra money for basically nothing, right? Like, she's not getting anything out of that. Well, I guess what she's getting is the ability to pay her bills back. So that's good. But then she's gonna have to pay this back eventually too, and it's gonna cost her. Now, I don't know if any of you have a credit card, like in your own name, but credit card rates are usually much higher than that. It is extremely important that you guys pay off your credit cards as you go, rather than let the interest build on it. Because that interest builds, you might have a credit card that has 20, 30% interest rate. It's a crazy high number. If you let that go, you're going to just basically flushing money down the toilet. So make sure that you're responsible with your credit cards. Anyway. Okay, so that's simple interest. So that's just a little formula that you can use to calculate how much interest gets applied to these loans or investments. But what we're going to talk about next is really going to be the major focus for today, and that's compound interest. Any questions about this problem before we go on to compound interest? So with compound interest, this formula I'm going to give you is going to not just calculate the interest, but actually calculate the final value of an investment, or on the flip side, the total amount you pay on a loan. So it actually does the total amount, or it does the interest plus the principal kind of baked into the equation. Okay, and the way compound interest works is, if you go to different banks or you want a loan, one of the questions you should be asking is, like, how is the interest being compounded? Because depending on how often they apply the interest, the total value of the investment or the total cost of the loan is going to be different. And what I mean by that is sometimes interest is applied monthly, right? So once a month, they'll apply the interest and they'll basically add on a little extra charge there. Sometimes it's annually. Sometimes it's weekly. Sometimes it's daily. It all just depends on whatever plan you sign up for. So, but that is going to affect like how much you have to pay back. Okay. So with compound interest, there will be like a certain number of times that interest gets applied. Now, one thing that we're not going to go over today is something called continuously compound interest. And that is when like the number of times that it's being compounded is effectively infinity, meaning like it's just always compounding. Now, we're not going to get into that today, but just that there is that's kind of out there too. So let's break down what all these little letters mean. I think most of them you'll find pretty intuitive, especially based on those previous problems. The A here, that's the final amount. So that's the final like value of the investment, or on the flip side, the total amount that you would pay back for the loan. Okay, in other words, it's the total amount. It's the principal plus the interest. So it like adds those together for you essentially. The P is still the principal. So that's the initial amount. And this function is an exponential function. Like, even if we go back to the very first day when we were talking about exponential functions, we wrote these functions as like y equals a times b to the x, right? Where a was the initial value and b was that constant multiplier. And both of those are just essentially broken down, or not a, I guess it's the same as b, but b is broken down to figure out like, how do I actually calculate that b? And it's based on the rate and the number of times that interest is compounded. So like the A, the initial amount is the principal. Like that is just a different letter, but it's playing the same role in the equation. The B is calculated here. And the X, which we usually just use as like time, is going to be a little different because interest is going to be compounded like multiple times in a year. So like if interest is compounded twice in a year, you have like 2 times the number of years, which is why that exponent is not just the t. So yeah, let's break down the rest of these. R is the interest rate, just like in the simple interest. And we're going to express that as a decimal. The n, this is a new variable, is the number of times that interest gets compounded per year. So the number of times per year that interest is applied or compounded. And then finally, t is time. And for all the problems we're going to work on, it's going to be in years, although you could adjust to this formula for another time increment. Okay, so a lot going on here, a lot of variables here, but really, like at the end of the day, these problems are not as hard as it might seem. The challenge is just basically reading the problem and picking out what all the numbers are and just kind of plugging them in where they go. One last thing before we start working problems here is that this whole number of times that interest is compounded per year is almost never going to be explicitly stated in the problem. It's not going to say like, oh, it's compounded 13 times a year or something like that. Instead, it'll be worded in a way where there'll be like some vocabulary word that will indicate how many times per year interest is compounded. And these are the most common ones. There obviously are some other ones out there. But like for instance, if interest is compounded annually, that means 1 time per year. If it's compounded quarterly, that means interest is compounded 4 times per year. Monthly would be 12 times per year, and daily would be 365 days per year. And so, there's probably other ones out there. These are the most common. But the way that problems are going to be worded is they're going to use one of these terms to indicate how many times per year interest is applied. So you want to be on the lookout for that little word. How is interest being compounded? There's some other words out there too, like semi-annually, which means twice a year. You can even do like weekly or by the minute. There's a lot of minutes in a year. But whatever it says, that's how you're going to calculate the end value. So let's look at a few examples here and see how we're actually going to solve these. So example 4 says, suppose $1,800 is deposited into an account that pays 5% annual interest compounded monthly. Find the balance after 2 years. So the initial amount, the principal, is $1,800. That's our P value. Okay. The account pays 5% annual interest, so that's the rate. As a decimal, it'd be 0.05. And it says that interest is compounded monthly. So what's the end value if we're compounding monthly? How many times per year is interest being compounded here? Yeah, 12. Yeah, there's 12 months in a year. Good. Okay, and it says find the balance after 2 years. So the t value is going to be 2. So I'm going to write the formula one more time so I don't have to slide back to the other slide here. So A equals P times 1 plus R over N to the power of NT. We're just going to substitute in those 4 numbers into the equation and use the calculator to compute the final value. So you don't have to actually solve for anything here. It's just a matter of making sure you're picking the right numbers and putting them in the right place. So the final amount in the account is going to be $1,800, that's the P, times 1 plus the rate, which is 5% or 0.05, divided by 12 to the power of 12 times 2. And yeah, this is just something we'll put in the calculator. So let's see here. We've got 1,800 times 1 plus 0.05 over 12, power of 12 times 2, or just 24, I guess. And so the amount of money in that account after 2 years is $1,988.89. Any questions about that one? All right, I just have two more examples for you. They're both going to work out very similarly. Okay, so example 5 says you invest $1,500 at a rate of 3.5% compounded annually for 4 years. Find the balance after 4 years. So the 1,500, that's our principal. The 3.5%, that's our rate, and we'll write it as a decimal. Be careful with the 3.5. It's going to be 0.035, not 0.35, because you need to divide it by 100. And it says it's compounded annually. So if something happens annually, it means that it happens once a year. You know, like watch the Oscars or something. It's like the 74th annual blah, 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 right? It happens one time per year. So that means our end value is 1. And then the amount of time that we're measuring this over is 4 years. So that's our T. Okay, so the amount in the account, I'll just write the formula one more time here. Doesn't hurt. Is going to be 1,500 times 1 plus 0.035 over 1 to the power of 1 times 4. And you could, obviously simplify some of that, divide by 1 times 1. You don't need to write those ones, but I'm just going to lay them in there so you know exactly where each of those numbers are going. And again, this is going to be just something we throw in the calculator. So we got 1,500 times 1 plus 3.5% over 1 to the power of 1. Let's try that again. 0.035 over 1 to the power of 1 times 4 is $1,721.28. All right, one last example here. Any questions about number 5? Hopefully you're seeing that, the formula looks a little scary there. There's a lot of variables in there, but these kind of problems are usually pretty easy to solve because all you need to do is just make sure you're putting the right numbers in the right variables. Okay, number 6. In May 2011, a single Bitcoin cost approximately $3.50. Sarah invested $1,000 into Bitcoin at this time. Since then, the price has increased at a rate similar to that of a savings account that compounds interest annually at the rate of 105%. Which is that's pretty good. Using the compound interest formula, estimate the value of Sarah's Bitcoins in May of 2024. Okay, so the initial investment here is $1,000. That's our principal. Okay, since then, the price has increased at a rate similar to that of a savings account that compounds interest annually. Okay, so that means once per year at a rate of 105%. So the rate is going to be 1.05. The only variable we're missing here is time. And so that's not explicitly stated, but if we started the investment in 2011, and now we're trying to find the final amount in 2024, we just need to subtract those 2 years to figure out how many years have gone by. So from 2011 to 2024, let's do 2024 minus 2011, that's going to be a total of 13, right? Yeah, 13 years. So that's the T value. All right, anyone want to take a guess before we throw this in the calculator? How much our Bitcoins are worth? She invested $1,000 in 2011. The cost was $3.50, but the rate is kind of ridiculously high, 105%. Let's find out. So the final amount is going to be the principal, $1,000, times 1 plus 1.05 over 1 to the power of 1 times 13. Now, it doesn't say how many Bitcoins she has, but if they cost $3.50, and she invested $1,000. She's probably got what, like 100 something Bitcoins or something like that. So let's see here, 1,000 times 1 plus 1.05 over 1 to the power of 13. And here we go. Final amount of her investment in 2024 is $11,292,762.48. So not a bad investment. Yeah. All right. Any questions?